Around 300 BC, in Alexandria, the greatest intellectual city in the ancient world, a mathematician named Euclid sat down to do something that had never been done before. He was going to organize all of geometry from scratch. The result was the Elements, 13 books that organized all known geometry into a single logical system, built from 5 simple starting assumptions. It became the most successful mathematics textbook in history. It was still being used in schools in the 20th century. The genius of the Elements was its foundation. Euclid began with just 5 postulates, 5 statements assumed to be true without proof. A straight line can be drawn between any 2 points. All right angles are equal. And so on. From these 5 seeds, he grew all of geometry. The method was as important as the results. Every theorem in the Elements is proved, rigorously, step by step, from the postulates. Nothing is assumed beyond what was stated at the start. The Elements was not just geometry. It was a demonstration of how knowledge should be structured. The Elements survived the fall of Rome through monastic copying and Arabic translation. For over 1,000 years, it was the standard mathematical text in Islamic and European universities. More editions were printed in the 1st century of the printing press than almost any other work. Every Renaissance scientist and mathematician learned geometry from Euclid. Copernicus, Galileo, Newton. The Elements was not background reading, it was foundational. The logical structure of the Elements became the template for how scientific arguments should be presented. For 2,000 years, learning geometry meant learning Euclid. Students across cultures, Greek, Roman, Arabic, European, began their mathematical education with the same propositions, the same proofs, the same logical structure. The Elements created a global mathematical language. Euclid's proof of the Pythagorean theorem, proposition 47 in Book I, is considered one of the most beautiful proofs in mathematics. It proceeds from first principles with perfect logical economy, arriving at its conclusion with a clarity that has astonished readers for 2,300 years. Euclid's 5th postulate, the parallel postulate, troubled mathematicians for 2,000 years. It seemed less obvious than the others. Mathematicians spent centuries trying to prove it from the first 4. They failed. Because it is genuinely independent, and its removal creates entirely different, valid geometries. In the 19th century, mathematicians Gauss, Bolyai, Lobachevsky, and Riemann explored what happened if you abandoned the parallel postulate. They discovered non-Euclidean geometries, curved spaces where parallel lines can meet or diverge. Einstein later used Riemannian geometry to describe the curved spacetime of general relativity. Euclidean geometry remains the foundation of practical design, architecture, engineering, cartography, computer graphics. Every straight line, right angle, and circle in the built world is constructed using principles established in the Elements. The book that organized geometry still organizes the world. Every 3D model in computer graphics, every game, every film, every architectural visualization, is built from Euclidean triangles. The GPU in your computer is, at its core, a machine for performing Euclidean geometric calculations billions of times per second. Euclid runs your screen. From Euclid organizing geometry from 5 postulates in Alexandria, to medieval monks preserving the text through centuries of chaos, to Renaissance scientists using it as a template for all knowledge, to Einstein using non-Euclidean geometry to describe curved spacetime, to the GPU calculating Euclidean triangles billions of times per second. 5 postulates. Infinite reach. I am Takku. Euclid's Elements endures because knowledge, when properly ordered, transcends time itself. This ancient text teaches us that human progress builds upon clear foundations. Until we meet again, keep seeking truth.